All right, so in example 3, we got another limit that we want to evaluate. And before we can apply L'Hopital's rule, we have to make sure that it is one of those proper indeterminate forms for which L'Hopital's rule applies. So let's take a look at the limits of the numerator and denominator as x approaches, oh, that should be t, shouldn't it? T approaches 0. All right, so what do you get? When you evaluate the numerator, e to the 0, that's 1 minus 0. All right, so that's equal to 0. And the denominator is just 0. All right, so we have this 0 over 0 indeterminate form, so we're good. We can apply L'Hopital's rule. All right, so we're going to just look at the limit as t approaches 0 of the derivative of the numerators and denominators. So the derivative of e to the t is e to the t, derivative of -1 is 0, derivative of negative t is -1. And the derivative of the denominator is 2t. Alright, so let's see what happens. If we look at the limit of the numerator, we get e to the 0 minus 1, which is 0. The limit of the denominator is 0. Alright, so we have another 0 over 0 problem. But we can apply L'Hopital's rule again, right? Because we still have an indeterminate form, and that we can apply L'Hopital's rule too. So I'm going to look at the limit as t approaches 0 of the derivative, right? So I'm going to get e to the t over 2. And now when I evaluate the limit, e to the t at 0 just becomes 1, and of course 2 is just 2. So our limit is 1/2.